So for examples like the reader-writer example, we have basically this common building blocks. The actual operations to the shared resource, the shared file, so the reads and writes of the shared file in this case, have to be protected with these code blocks, enter critical section and exit critical section. Each of these code blocks internally follows basically the critical section structure that we outlined just a couple of screens before, where they lock a mutex, they check for a predicate. If the predicate isn't met, they wait. The wait is in a while loop. And if the while is okay, a predicate potentially gets updated. When we're done with the actual operation, the exit critical section code, again, in one of these lock constructs, we have to update the predicate. So here we have really nothing to wait on. We just want to update the predicate and then signal and broadcast the appropriate condition variable. The mutex is actually held only within these enter critical section and exit critical section code. So if you see, it is unlocked at the end. And this allows us to then basically control the access to the proxy variable, but to allow more than one thread to be in the critical section at a given point of time. This lets us benefit from mutexes because mutexes allow us to control how a shared resource is accessed. However, this type of structure also allows us to deal with a limitation that mutexes present because they allow only one thread at a time to access that resource. So with this structure, we will be able to implement more complex sharing scenarios. So in this case, the policy is that either multiple threads of type reader can access the file or one thread of type writer can access the file. The default behavior of mutexes alone doesn't allow us to directly enforce this kind of policy. Mutexes only allow the mutual exclusion policy.